Hey kiddos, what is up? Um, we're going to be talking about proving parallelograms now. So, few things to recall, basically. Parallelogram, opposite sides converse. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, if AB is congruent to DC and BC is congruent to AD, then ABCD is a parallelogram. We also have if parallelogram opposite angles converse. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, if angle A is congruent to its opposite angle, which is angle C, and angle B, which is opposite of angle D, are congruent, then ABCD is a parallelogram. Opposite sides parallel and congruent theorem. If one pair of opposite sides of a quadrilateral are congruent, so as you can see here, we got BC is marked as congruent to AD, and they're marked as parallel, then the quadrilateral is a parallelogram. Okay, so if you have both of those instances, then you can prove that ABCD is a parallelogram based on opposite sides parallel and congruent theorem. Next, we have parallelogram diagonals converse. So, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So notice I have diagonal AC and diagonal BD. As they cross at their point of intersection, they bisect each other, which means they split each other into two congruent pieces. So therefore, that justifies that ABCD is in fact a parallelogram. So, ways to prove a quadrilateral is a parallelogram. So basically, what we have here is 1, show that both pairs of opposite sides are parallel, which basically is the definition of a parallelogram. Okay. Number 2, you show that both pairs of opposite sides are congruent, which is the parallelogram opposite sides converse. Okay. 3, show that both pairs of opposite angles are congruent. That is the parallelogram opposite angles converse. 4, show that one pair of opposite sides are congruent and parallel. So notice it has to be the same side, but be both congruent and parallel, and that's opposite sides parallel and congruent theorem. And finally, 5, show that the diagonals bisect each other, which is the parallelogram diagonals converse. So these are 5 ways to prove that a quadrilateral is actually a parallelogram. All right, so here's our next example. In quadrilateral ABCD, AB is congruent to BC, and CD is congruent to AD. So is ABCD a parallelogram? Well, hopefully you guys are seeing that if it is a parallelogram, then opposite sides are supposed to be congruent. So that would lead us to conclude then that no, this is not a parallelogram. Okay. Why? Because opposite sides are not congruent. This description is actually a description of a kite, but that's a different quadrilateral that we'll learn about later on. So moving on to example 2. All right, so for this next example, for what values of x and y is quadrilateral PQRS a parallelogram? So notice here they've labeled all of our sides. So if we're establishing that this is a parallelogram, then we know that PQ is going to be congruent to SR, and that PS will be congruent to QR. So the first thing that we're going to use is that PQ is congruent to SR. So therefore, we're going to set x plus 9 equal to 2x minus 1 to figure out what the value of x is. So x plus 9 equals 2x minus 1. All right, I'm going to subtract x to both sides so I can get my variables together. So we get 9 equals x minus 1. Then I'm going to add 1 because I'm trying to get x by itself to both sides, and we basically get that the x is 10. So now to figure out y, notice here I'm going to use the information from Q to R. We know that QR is congruent to PS, and PS is Y. So essentially what I have to do is I have to plug in the value of X, which we discovered is 10, into this expression here of X plus 7. So when I do that, you get 10 plus 7, which is 17. So Y is 17. Next, for what values of X and Y is can't speak. It's like a tongue twister. Quadrilateral STUV a parallelogram. Show all your work. This is an OYO problem, which I know you got it because it's just like the problem I did before. So, get it done. All right. Example 4 says, in quadrilateral WXYZ, the measurement of angle W is 42, the measurement of angle X is 138, and the measurement of angle Y is 42 degrees. They want us to find the measurement of angle Z. So, is WXYZ a parallelogram? Yes or no? Explain your reasoning. So, let us recall that the total interior sum of a quadrilateral is 360 degrees, which means that angle W plus angle X plus angle Y plus angle Z should equal 360. So we're going to go ahead and write this out mathematically. And yes, I do expect you guys to all show your work. I'm just going to put Z, since we don't know what that one is yet, equals 360. And when I add up those numbers, because I'm combining my like terms, you get 3 2's, 222, plus Z equals 360. All right, so I'm going to subtract the 222 to both sides. They cancel out on that side. And we get that the measurement of angle Z is 138 degrees. So the measurement of angle Z is 138 degrees. Now, if I draw myself a little visual here, and obviously, yeah, it's not going to be very accurate looking. That is W, X, Y, and Z. W was 42. X was 138. Y was also 42. And we conclude that Z is also 138. And we can note here that the opposite angles are, that's right, they're congruent. So, is it a actual parallelogram? Why, yes, it is. And why is that so? Because opposite angles are congruent. All right, so example 5, find the diagonal lengths of a parallelogram. For what value of x is quadrilateral CDEF a parallelogram? Explain your reasoning. So you can see here that we have two diagonals, and if in fact this quadrilateral CDEF is a parallelogram, then we know that these diagonals are supposed to bisect each other. So if this piece is congruent to this piece, then we know that Fn is going to have to be congruent to Dn. Okay, so to mathematically figure out the value of x, we're going to simply take 5x minus 8 and make it equal to 3x. All right, I'm going to subtract 5x to both sides. We get negative 8 equals negative 2x. Last step is going to be to divide both sides by negative 2. We get positive 4 equals x. So we know that x is 4. The reasoning here is that diagonals are bisected. And if I wanted to go a step further, let's say I actually want to know what is the value or the length of Fn, and obviously dn would be the same. So to figure that out, 5x minus 8. So if you plugged in the value of 4 here, you have 5 times 4 minus 8. And we know that 5 times 4 is 20. And if you take away 8 from that, you are left with 12. Okay, so don't always forget. It's always good to pay attention to what the question is asking for. Because remember, I like to try and stump you guys sometimes. And you guys always just give me this and don't actually answer questions full out sometimes. So make sure you pay attention to that. But that was just a little extra for this one. So moving on. For what values of x and y is quadrilateral ABCD a parallelogram? Explain your reasoning. Now, for this problem, we're looking at angles. Now, the one thing that we do know that's going to help us with angles for parallelogram is that opposite angles are supposed to be congruent. So, angle A would be congruent to angle C, and angle D would be congruent to angle B. So if that is the case, then we're going to set them equal to each other. So let's deal with the x first. So that is 3x minus 32 equal to 2x. All right, I'm going to subtract 3x to both sides. Those cancel out. Bring down the negative 32 equals, well, that leaves me with just a negative x. Can't have a negative x, though, so I got to divide both sides by the negative 1. And we get x to be 32. All right, so that's that first part. Now let's look for y. Y, so that's angle D and angle B are congruent. So 4y equals y plus 87. I'm going to subtract y to both sides. Left with 3y equals, those canceled out, 87. Last step is going to be to divide both sides by 3. And we get that y equals 29. Now, if we want to really double check and make sure that we did this right, because we should end up with the same values, let's say we actually plug that in. So if I did 2 times x, which is 32, then this angle here is 64 degrees. Then if I do 3 times 32, I get 96, and I take away 32 from that, I also get 64 degrees. So far, angle A and angle C check out. Let's check the other two angles. So y is 29, so 4 times y, or 4 times 29, leaves us with this to be 116 degrees for angle B. So let's see if angle D is the same, which it should be. Y is 29, so you got 29 plus 87, and eureka! It is also 116. So we can conclude that quadrilateral ABCD is in fact a parallelogram because opposite angles are, shorthand, congruent. So for example 7, I'm going to let you guys handle this on your own. Oh, yo. So all you're simply doing is stating the theorem that you can use to show that the quadrilateral is in fact a parallelogram. Okay? So just tell me basically what theorem works to justify this is a parallelogram for A, B, and C. All right, so let's apply this to the real world. So the doorway shown is part of a building in England over time in which the building has leaned sideways. So this is actually really real. Okay, so first thing is explain how you know that SV is congruent to TU. So notice what we have here is we do have markings on ST to VU. And I see that they're marked as parallel and marked as congruent. So if ST is congruent to VU and ST is parallel to VU, then we can establish that STUV is a parallelogram. Why can we say that it's a parallelogram? Because opposite sides are congruent. So therefore, that would lead us to conclude that that SV has to be equal to TU, because it would have to be congruent to each other because they're opposite sides. All right, next. Well, since we have established already that STUV is a parallelogram, I can't even spell parallelogram. Okay, so since we've already established that STUV is a parallelogram, then we already know, based on justification here, that opposite angles are congruent. So angle S here has to be congruent to angle U. Why? Because opposite angles are congruent in a parallelogram, and we've established that it is a parallelogram. Okay, so example 9. Graph the quadrilateral with the given vertices in a coordinate plane. Determine whether quadrilateral is a parallelogram. Explain your reasoning. So as you can see, I've already took the time and plotted my points and drew my quadrilateral. Okay, so kind of like before, to help find or justify that these sides are the same, we're going to use slope, aka rise over run. So let's determine what the slope is of W to X. So I would have to, so from X, I'm going to go up 1, 2, 3, 4. So I went up 4. That's positive. And then I'm going to the left, 1, 2, 3, 4, 5, 6. Left makes it negative. When I reduce that, that reduces to negative 2/3. Now, hopefully I get this exact same slope for ZY. If I do, then we're on the right track. If I don't get the same slope, then we can stop right there and we can already justify that this would not be a parallelogram. So let's check out ZY. So I'm going to start from Z and I'm going to go down 1, 2, 3, 4. So if I go down 4, that's negative, over, going to the right, 1, 2, 3, 4, 5, 6. What do you know? Same answer when I reduce. So far, so good. Now let's look at the other two sides. So I can justify making those markings there. Now let's look at the other two. Let's start with WZ. So from Z, I would go up 1, 2, 3, 4, 5, 6. So I go up 6, so that's positive 6. And I go over 1, 2 to the right, so that's still positive. And that gives me a slope of 3. So we're going to hope that XY gives me the same slope. So here, let's start at X. We're going to go down 1, 2, 3, 4, 5, 6. Down 6. Ooh, that's negative 6. Over and then to the left. 1, 2. Left is negative as well. That actually does reduce to a positive 3. Check, check. So the answer is yes. And it's because we can justify that the opposite sides, we can't justify that they're parallel, or not that they're, we can't justify necessarily that they're congruent. We'd have to take it a step further and like actually either use the distance formula to prove it, or we could actually use Pythagorean theorem, because we basically created right triangles here to prove that these two values are the same. So what we really just proved by using slope is that these two lines are in fact parallel. So we proved that WX is parallel to ZY because they have the same slope, and that ZW is parallel to YX because they have the same slope. So yes, because opposite sides are parallel. And of course, why not end it with an OYO problem. So it's actually very similar to the problem we just did together. So you're going to graph the quadrilateral with the given vertices, okay, in your coordinate plane, and then you're going to determine whether they are, whether it creates a parallelogram, okay, and then you're going to explain your reasoning. So you're going to plot these 4 points, connect them, so you draw a quadrilateral, okay, and then you're going to find their slopes and see if they're parallel. If they are, then you know it's all gravy and it's a parallelogram. If they're not, then it is not a parallelogram. Got a little bonus for those of you who actually stayed listening and didn't cut me off for you. So don't tell anybody about this opportunity, okay? But it's going to be 5 points on a quiz. If you can find the original name of that building with the crooked door that was in a previous example, I want the original name of the building. Like I said, don't tell nobody. Keep it a secret. Hopefully you can find it. Adios.